So I'm here to talk about async view controllers. My name is Tom. Some of you may know me as Inferis on Twitter. So view controllers, everybody knows this. A lot of our code lives in view controllers. They're used to display data to the user and to let the user interact with the data we have in our apps. It's a standard and well-known mechanism when developing iOS apps. It's actually the only way of doing it, I think, unless you're Lauren Brichter, who writes OpenGL apps, but most of us do it this way. So, but most of the data we use, it's not local, it's or even static. It comes from kind of a slowish source, and it's not immediately available. So then we get to the async part. A most obvious example is network data. So if you get something from a network, depending on where you are, it can take a while. But it's not only network data, it can also be a location fixes when you want to get a GPS fix. Also, depending on where you are, it can take a while before you actually get one. Or if you have a complex core data database or something else database, and you want to make a complex query, also that data is not immediately available. It can take a few seconds, maybe a few milliseconds, but it can take a while. So there's a need to display something to the user while the data is being fetched, whatever data it is. Now, like mentioned before, David Smith says if you show a spinner, it's not good, but sometimes you just can't get by it. And depending on what kind of work you do, if you make your own app, you can spend a lot of time reducing the spinners, but if you do consultancy jobs, like I mostly do, you don't have the budget to try to make it as it should be. If you can do it, go for it, but it doesn't always work that way. So this is a solution that we use in an app we made. Now, how does async data work? So how does it work? Normally, you start a slow call, then you show, hey, wait, I'm busy, spinner or indicator, whatever. Wait for the call to finish, remove the spinner, and then show your actual data. Now, if you have a lot of data in your app, and you have more than one call to do, it can become quite repetitive. If you have to do the showing the spinner, wait for the call, and hide it again, several times, it's a lot of duplicate code. So it makes sense to make a common component to do it for you. So you only have to write it once, and it will always be the same in your complete app. So some history. How did we get to it? So I was in the same boat. We had to create a large app. My current role is as a lead developer. I work for a company called iCaps in Antwerp. And I was hired to make 2 iOS apps for a trading platform called Bolero. And their 2.0 platform was written in Flex. So that doesn't work so good on mobile devices, so they wanted a 3.0 version, which was going to be a rewrite from the ground up, featuring a whole new website and 2 mobile apps. They created a REST backend just for the new version, which meant that we had a lot of separate calls. Now, we built the iPhone app first with a dev team of about 5 people, including me. And the screen we will see is one of the 5 parts of the main screens in the app. Each large screen, has several subscreens with each its own data call. Now watch carefully because it goes quite fast, but take a look. So you see that the data comes in asynchronously. All the calls are going in the backend. We started them, we wait for them, and then you have to show something. Now, in a screen like this, it's not too complex, but there's several small screens. Where's my presentation? It's still here, but not there. I didn't touch it. Do you see it here? No. It's gone. Don't you love technology? There we are. So we released the iPhone app in June 2014, so that's almost a year ago. But by then we had 5 problems. We we had massive view controllers, 5 of them, 1 for each screen. There's a lot of interaction for each screen. There was a lot of kind of double-ish code for fetching data and getting it on screen. It was hard to navigate, a lot of files, large files, very difficult to maintain with a team of 5. For example, 2 of the screens we have on the app, the one you saw is a hotspot. It contained 2 large components. We already split at that point into 2 separate classes. But you can see that the total for the hotspot is 1,055 lines of code. That is a lot of code. Now, there's not a lot of code. Not everything is there. There's also code we use to display the views. We need that anyway, so that doesn't count here. This is just the interaction, fetching data, and making sure everything gets where it needs to be. So, to give you an idea, that's too much. We couldn't do that. Now, the problem was that after the iPhone app, we had to make iPad app too, which was even more complex than the iPhone app. The team grew to 8 people, and the video now shows the iPad app for also the hotspot, which gives you an idea of how complex it should be. There are 10 screens like this one in the app. Searches. You see a lot of the same components as the iPhone app, but slightly different. Even this is quite asynchronous. So while we're loading all the data, the app doesn't come to a full stop. Now, that's normally what you should do. But to make this was quite complex. And if we had to take the approach we took with the iPhone app, it would be too much technical depth and it would be wrong. So what we had to do was to break things up. As a side effect, we had to split our code base into the iPhone app code base and the iPad app code base. Maintenance for iPhone, because there were bug fixes we had to do, and development on the new iPad app. That was interesting. But then we introduced AsyncView Controller. Everybody endorses AsyncView Controller. Basically, it looks like this. Now, the original version was a bit more complex than this, but that's the key part. Now, I'm not sure if I'm the first one, but why no Swift? First of all, the code base we worked on was Objective-C, so I took part of the code and reused it in this code base. And secondly, this is a problem. Mainly, this is a problem. You can't do this in Swift. You can't say, I need a class, and I want that class to conform to a certain protocol. You can't make a combination at this moment with a type declaration. I even asked this on Twitter and got a response from one of the Swift guys at Apple. He says, OK, you can do it as a generic parameter, but you can't represent that as a type. So that made me sad. I want to do Swift like everybody, so that doesn't work. But I filed a radar for this. You can dupe it if you want. That would be awesome. And perhaps they'll implement it. Now back to the Async View Controller. It looks like this. There's 3 main components. The Async View, the status view, and a perform async data request call. Now you can see it's a subclass of UI View Controller. As I mentioned before, we get all the UI View Controller goodies for free. People know this, so it's not too complicated. You can keep on using nibs or zips and storyboards. It just keeps on working. And the best part is we can use View Controller containment. I'll get back to that later. Now, the first part is the async view. It's just a view which conforms to the async view protocol. And the protocol defines how we pass data to the view. So it provides a uniform way of passing data to a view. No complex models, no several properties, just one to set the data. There's the async status view, which is a wrapper view around the async view we mentioned before. It only shows the async view when it has to, so when there's data that's been delivered. In the meanwhile, it can show other views to show a spinner or something else, or an error message when there's something went wrong. So it's, again, a uniform way of showing intermediate states. And then finally, the perform async data request is an empty, by default, method, which is called automatically by the controller. And you're free to do whatever you want there. If you set data right away, it works. If you wait for a network call to come back, it works. If you use GCD, it works. So this doesn't define how you should do it, but you can do whatever you want. Now, if you have these three together, the async data fetch, the two views, and the view controller containment, you can make a powerful combination with this. So the controller fetches the data it only needs to be, doesn't care about the rest. The status view handles the intermediate state while fetching the data or something went wrong. The async view shows the data when it's there, triggered by the status view, and this is only for one little part of your app. So you don't make massive view controls, you make a lot of small view controllers doing only their parts in the flow. Now, this is a bit of a single responsibility principle. Each controller is responsible for its own data and not the data for the other ones. It knows where to get it, how to get it, and how to show it. There's only separate calls needed for separate data. If you need more than 2 calls in one view, you might consider breaking the view up into several view controllers, if that's possible. If you do need to aggregate the data, then you have to do that somewhere else, in a backend or in a subsequent layer after the backend between a view controller and the view. Don't put it in a view. Normally, 1 call for each view controller. The great thing about this is that it's become much easier to test your view controllers. They're just single responsibility. You can test whatever you want, just the actions you needed for the view controller. Also, it brings us a more pure MVC, like Marcel said before, not the Apple MVC, but the actual MVC. There's no presentation management in the view controller. It's just in the view. The controller only fetches the data, and it interacts with the rest of the app. If somebody clicks a button in the view, then the controller can react to it through the view, and then have a notification sent or whatever. There's no business logic in the view itself. It only gets data and has to show that data. It doesn't care where it comes from or how is it represented. It just shows the data. So that's the most important part about the controller. The way we designed this was that the extended API would be simple enough to use for people not knowing this system. You only have to implement one method, implement a view, something you need to do anyway. And then, optionally, you could customize a status view, but that's not necessary. You could do it once, and then you can use a status view for all the components. So it's easy to use. If you do it once, you can do it twice, and it's a very common pattern. Now, the APIs are also open to extension. So we rely on protocols instead of classes. So you don't have to subclass. You can do whatever you want with your own classes. If you have views of your own and you want to adapt them to the async pattern, you only have to implement the protocol, and that's it. If you implement the protocol as it should be, it should work out of the box. You can do the same with the status view and with the async view. If you have more generic implementations doing several things in the same classes, you can subclass the async controller and do more work on beforehand, or whatever you want. So you can still use the same techniques as you would do it now. And finally, breaking things up makes things testable. So the view controller is fully testable for interaction between the async view, between the status view, for transitions between statuses. It's only defined once, and it's easy to test. You can also test each view separately. If you just pass in some data, you don't have to care where it comes from. Make some mock-up data, pass it to the view, and make sure the view looks like you expect it to be. And even if you don't want to write this or have time to write this, because you should write this, but if you don't have the time, at least it forces you to think in a way that like you would write tests, which is also anyway better than doing nothing for testing. So if you think about your code, would this be testable? It's a win anyway. So we're finally getting to the code part. Enough with the babbling. This is the Async View protocol. Now it's very simple again. It only has 2 major parts: the async data, which contains the data you want to visualize in the view, and a method called async data apply value animated. The data property, I will get to that later. How does that work? So the method is the single point of implementation for your visualization. This is called by the controller or by the status view when there's actual data. So when you get this call in your view, then you know you have data you can show. How you show it doesn't matter. You can do animations, whatever you want. There are also a few optionals. I will get to them later. Now, this is the AsyncData protocol. It has 3 major properties. Now, a loading indicator, which is read-only, an error property, and a value property. And also a reset method to reset the state. These 3 properties represent the states you can be in. Your data can be loading. Nothing is there, so the view is in the loading state. The data is in loading state. When there's something goes wrong, you go to the error state. When you get a value, you pass in the value to the value property. And what happens is that we get these 4 states in our app. The loading, error, no data if the data you got is, your call was correct, but you didn't get any data back. You might want to show a different kind of UI than when the data is there. And there's a data statement. Now, that looks a bit like this. I'm not sure if it's readable or not in a diagram. So initially, we are in a loading state. So when you show the view right away, it just shows a spinner. Now, if you set the data, then you go to the data state. If you reset, you go back to the loading state. If you set an error, you go to the error state. If you reset, you go back to the loading state. That's all the async data has to do. The data can be whatever you want. Can be a string, can be a complex object. You can choose. Now, checking for state becomes really simple. When we get a callback from the view that the state has changed, all we have to do is check for certain properties in certain order. For example, if the view is not loaded yet, or it's still loading, then we have to show a loading spinner. If there's an error, then we have to show an error. If there's a data value, then we can show that data value, and otherwise there's nothing to show, but we want to show something. So how those changes are communicated is through the AsyncDataDelegate. It's another property on the AsyncData view. What that does is, you can see the signature below. When something changes, the data knows what changed and says, OK, something changed, react to this. That's all it does. You can also ask to reload the data. So if you say, OK, my data is invalid, I need to update it. For example, you have a pull to refresh action in your view. You want to reload your data. You can call this method on the delegates. The delegate is, in this case, our view controller. Now, back to the async view. The optionals are 2 little methods you can implement. Doesn't have to be like that. So the async no data message is a sort of message you can show when there's no data. It can be whatever you want. No data acquired, or this is not the data you're looking for. If you implement it, that will be shown in the status view as a sort of message. It can be a string, can also be an image. You can do whatever you want. It's ID, doesn't have to be a string. Now, the async can reload method is used also by the status view. If there's an error, you might want to try to allow the user to reload the data. It might be a timeout, and you want the user to perform the action again so that the data might get there. So this method asks the view, can you reload the data? And then finally, the status view. That's the one wrapping the async view. So it has a reference to the async view because it has to add it as a subview. And it has a few methods to indicate transitioning between different states. So it listens to the calls from the async data, catches them, and then calls the transition method. That's being called by the ViewController. So this doesn't care about state. All it knows is how to show state. How to go from what state to another doesn't matter. The controller calls one of the transition methods, and then the status view has to update itself to show that state. How it shows it doesn't matter. You can show the view anyway, the async view. You can gray it out. You can do an overlay. Doesn't really matter. Now, I've talked about protocols, but by default, there are implementations for each of the protocols. So otherwise, you would have to do, if you want to use a component, you have to write everything from scratch again. There are some default implementations. These are called exactly the same as the protocols, by coincidence. Now, some other methods on the ViewController. There's a method to reload the async data from the ViewController. Again, if you have a pull to refresh or some external reference, you can call that method, and then it starts reloading. There's an override method to load the status view. This allows you to customize that status view, except from the if you don't want the default implementation. And there are some callbacks like ViewDidLoad, things like that. That's called. Those are called when the state changes. You can react to that in the ViewController for whatever reason you want. So how do you use this? It can be very simple. You have a ViewController with a backend, which is really laggy, and we want to invoke a slow call. So we do that. We get a result back with a block, and what we do is we pass the result to the async data in the async view. If we get an error back, we do the same with the error. Now, we don't care about threading here. You can call this on the backend, on the background thread. Doesn't matter, because the async view will already be loaded. The call perform async data request is automatically loaded called in ViewDidLoad. So by that moment, the view is already there and loaded as it should be. And when the data gets there and is passed by the status view to the async view, and the method is called async apply data animated, that is guaranteed to be called on the main thread. So there's no code here needed to get back to the main thread or whatever to do cross-threading. You can just write simple code. It's very clear. When you have a view, there's no view implementation in the controller. It looks like this. It's just a simple label which prints the message we received or the value we received from our controller. And we can reload the data when there's no error. So anytime there's no data, we can say, OK, try again, and let's do it again. We can do whatever you want in this method. It doesn't really matter. So that's a simple example. I can maybe show you a bit of code, but depending on the time. So under the hood, how does it work? So in ViewDidLoad, there's these 4 steps. We wrap our view with the status view. Then we call the regular super did load. Then we do an update of the state so that we get right to the correct state. And then we do the perform async data requests so that we get the data. We do it in ViewDidLoad and not on beforehand, so that the data is only getting loaded when the user scrolls or shows a view on the app. If you want to do it earlier, you can call the view method, and so that the view gets loaded and this code gets called. Now, wrap with status view is pretty simple. If we already have a status view, we don't do nothing. We do nothing. And then we ask the view itself at that moment is still an async view. So you can define a view in your xip, which can be an async view. You can define, you can build it completely in an interface builder. It works as you expect. We take that view and we wrap it with the status view. And we pass the data delegate as the controller to the async data of the async view. And then we call setView again on the controller to have the status view as the wrapped view, as a root view of the controller. Now stop. There's a problem here. I don't know if you know top layout guide and bottom layout guide, but these were a bit of a pain in the ass. What happens is if you link a constraint to the top or bottom layout guide and then do magic with the views, of which I mean change the root view of the controller and change the hierarchy, those constraints to those layout guides will disappear. Which is not what you want, because if you attach a label to the top of your view, then it will be completely on top and not the spacing like you specified. So that doesn't work. Now, we can do a bit of magic to solve that. So what we do, we find the constraints related to the layout guides before wrapping them. Then we wrap the views. And then we, at the first layout pass in the status view, we just recreate the constraints. It's not that hard. So this is the code to find the layout guides. It's, you can find it in the code, in the example I will show. But what it does is it finds the view controller attached to the view. We need that, because that contains the layout guides. And then we go over all the constraints in the view and check if one of the two items in the controller is attached to the constraint. If so, we remember the constraint. We don't only remember the constraint, we remember if it's a top layout guide or a bottom layout guide constraint, and we also remember the old layout guide because we need it later. So that gives us a list of constraints we have to replace. Now there's a special line here, find ViewDelegate. I don't know how many people know about the ViewDelegate? Nobody? Okay, a few. So each root view of the view controller has an IVAR attached to it called ViewDelegate. You can search for it on the internet, or if you decompile UIKit, you can find it out. This is used to call back to the view controller for changes happening to the view. So we can misuse this to get to the view controller. It's a bit of magic. You have to use the Objective-C runtime here. So what we do is we ask for the IVAR. We have to do a bit of a detour so that the underscore ViewDelegate string is not in the code, because otherwise you might have problems with the app submission. So we do it a bit of a detour. Then we get the instance variable. If we got the instance variable, we just call it, we get the value from it, and normally we get a view controller. If it is not a view controller, we don't want it, so we return it. This is pretty future-proof unless they delete the ViewDelegate, which is not going to happen soon, I think, but we'll see. If the ViewDelegate is not there for one reason or another, it will just get nil back, and the code will break, but it won't crash. Hi, Apple, we're just misusing your code. Now, warning again, this might break your code in the future. There's no guarantee that iOS 9 will do the same as iOS 8. There's a longer bit of code here. It's used to reapply the layout guide constraints. So what it does is walks over the constraints we have, tries to match the old layout guides with the new ones, and then add the constraint again. That's all it does. And after that, we did this. We say, OK, layout again, and everything would be as we would expect to be. Now, doing things like this makes you feel like a real hacker, right? Objective-C runtime calls, you don't do that every day. Now, there's a little bit more to this than what I explained. There's more code, but that wouldn't be too long. So there's a demo project. I will mention it later on GitHub. You can check it out, and the code's pretty clear. Now, back to our massive view controllers. I don't know if you remember this. So we were at more than 1,000 lines at the original iPhone app. We got the time by the client. The client said, OK, you have time to refactor the iPhone app. So that we had the same approach we took for the iPad app, which was much more maintainable, back to the iPhone app. Now, the reduction is smaller than I expected, to be honest. There's still a lot of boilerplate code and a lot of interaction. But given the time we had, we're lucky to got that time. We reduced quite a bit. So the portfolio controller is 71% of the original controller. That's 30% code gone. The hotspot controller is 75% of the controller, the old controller. And the box controller was only 30%. So a lot of that code is just gone and somewhere else in smaller components. So there's a lot less implicit dependencies than before. If we would have more time than we got, we could have reduced this even more. But given the time we got, hey, that works for me. Budgets, you know how it works. So what's the takeaway on this? Embrace view controller containment. Make view controllers small. You can use a lot of them on the page. If you saw the iPad app, each little box you saw is a view controller. You can put them in collection views, whatever you want to do. It works as expected. So you can make view controllers for small data, for things you want to do one step at a time, and it removes dependencies between code in the same file. It removes boilerplate code. You won't repeat yourself. You can put code in common components. And best of all, it becomes more testable, and you know it will work as expected if you write good tests. Now, this code is open source. You can find it on GitHub. I'll post a link on the Slack, on Slack later on. And that was it. If you have a question, you can ask now or get in touch. I don't bite. Thank you.
Tom, thank you very much. So,